Let's begin. Today's October 29th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 7, 8, 19, 20, and 22. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our first digit, the triangle digit, and compares it to the number 3. So should the value triangle be less than 3? Should it be equal to 3? Or should the value triangle be greater than 3? Criteria card B will take a look at our last digit, the circle digit, and the Turing machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at the 3-digit solution, and the Turing machine will let us know how many ones there are. Are there no ones? Is there a single one? Perhaps 2, maybe even all 3 are 1. Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E again takes a look at our 3-digit solution, but this time it'll let us know a little bit about the structure, so to speak. The Turing machine can inform us that there are no repetitions in our code, as in the example 125, or it could tell us that there is a double number, as in the example 112, or it can tell us it's a triple number, meaning it's a single digit repeated 3 times, as in the example 222. And finally, criteria card F, again, we'll take a look at our 3-digit solution from triangle to square to circle, and will let us know a little bit about the ordering of those digits. One scenario is where the 3 digits are in an ascending order, meaning that they are increasing, as in the example 135, or the 3-digit numbers can be in a descending order, or basically decreasing from 4 to 2 to 1, or the 3-digit code could have no order. So let's take a look at the example of 231. Notice that it goes from 2 to 3, meaning it's increasing, and then 3 to 1, which is decreasing. Now there are other codes where it could be the opposite, where it's decreasing then increasing, but again it's that shift that is one way to define a 3-digit code to have no order. We've also seen from other puzzles where if you have consecutive equal digits, for example 112, that if you notice when you go from 1 to 1, there is no change. So that's another way to define a 3-digit code to have no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card B. Okay, so the Turing machine does not approve of my choice for circle. I did choose an even 4, but since Turing machine does not approve of it, it's basically letting us know that actually circle should be an odd digit. So let's go ahead and type that up in our notes in section B. And we'll state that circle is an odd digit. And since it is odd, that means we can cross out the evens in circle. So we can cross out 2 and 4. Okay, so the next thing I think I'd like to test is criteria card E. Okay, so in the Turing Machine, or sorry, for criteria card E, notice that we are stating whether there's repetitions or some duplicate digits. If you look at my proposal of 314, they are all distinct, meaning, yeah, there are no repetitions, and the Turing Machine agrees with that. So let's go ahead and type that up in our notes for section E. And we'll say that the solution has no repetitions. So basically all the digits are going to be unique. Okay. And I think the next thing I'd like to test is criteria card D. Okay, so in this case, we are adding our first two digits. So if I add 3 and 1, that gives me 4. 4 is less than 6, but the Turing Machine does not agree with that. So basically, we can conclude that the sum of the first two digits should either be equal to 6 or be greater than 6. So let's go ahead and type that up in our notes, and we'll put that in section D. And that again is that triangle plus square should either be, again, equal to or greater than 6. And that alone, I don't believe we can cross out anything because, even 1 plus 5 does give us 6 exactly. And of course, anything in between would be greater than 6. The only thing we can conclude, though not cross out, is obviously you can't have two small values in triangle and square. Well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. Now notice that we did not test criteria card A, comparing triangle to the number 3. We also did not confirm how many 1s we might have. And at this point, since we know that there are no repetitions, at most you have a single 1, or no 1s at all. And then also we did not test the ordering of our solution. So what could we be looking at? Obviously we do know that we have an odd in circle, and it's possible that both triangle and square could also be odd, but we could have some kind of a mixture of odds and evens in triangle and square. So let's see what could be happening here. So even though we do know that circle is odd, other than that, somehow maybe it's going to be forced into that value. It could be that it gets forced to be a 1, or maybe not being a 1, and somehow the ordering would force us to pick 3 or 5. That's always a possibility. And somehow, we know that the sum is either equal to 6 or greater than 6. And somehow, criteria card A would help us to figure out what square should be. And again, maybe the ordering has something to say about that. So what could be happening? Well, again, I guess it's likely it could be that triangle could be a small digit, forcing square to be a larger digit in order for it to be, for the sum to be either equal to 6 or greater than 6. So what could be happening here? How could we sort of decide what triangle and square are? Let's see. Well, we always could do a sum of 6, which would basically be either 1, 5 in some order, or even 2, 4. Could we be able to decide that? Which one to pick between the 2 odds and the 2 evens? It would also be interesting, let's see, trying to think of, is there a way to force all of them to be an odd? If we knew triangle were 3, well, no, not necessarily. I don't think there's a way to do that. All we can say is that there wouldn't be any repeats. So what else could we do? I guess somehow, again, if we were to say, yeah, the sum of the first 2 is 6, and say triangle is, less than 3, would that somehow help us decide whether it's 2 odds or 2 evens? Hard to say. I guess maybe if the sum were, say, greater than 6, and we knew triangle were 3, that would leave us with either 4 or 5. But then you would have 2 choices, 4 or 5. So no, I don't think, unless it was some sort of ascending, which would be 3, 4, 5, but I don't see that happening. Maybe, yeah, I don't see that. What if the sum is 6 and there's only a single 1? Well, yeah, I don't see that being the case either. What if the sum is 6 and there are no 1s? Well, that definitely would then simplify our choice to be 2 and 4 in triangle and square. And then perhaps maybe because of the ordering, it forces us to choose circle. So it could be something like 4, 2. Well, I don't think it could be 4, 2, because then how would you pick between 3 and 5? But if it was 2, 4, and then it had to be no order, it would be 2, 4, 3. Yeah, let's go with that, 2, 4, 3. Let's see where that takes us. Okay, so let's see, what could we test first? I'm hoping that I won't necessarily have to retest criteria card D, or maybe I can deduce criteria card F outright. So let's do this. Let's actually test criteria card A first. Okay, so it is not the case. I chose a 2 for triangle. 2 is less than 3. It's not the case that triangle should be less than 3. It's either going to be equal to 3 or greater than 3. Okay. So let's type that up, and we'll say triangle is either equal to or greater than 3. Now that does allow us to at least cross out 2 values in triangle. And let's see. since we know that the sum has to be equal or greater, so let's see. Well, yeah, no, I don't think we can cross out anything. I was hoping we'd be able to cross out something in square, but I don't think that's the case. Yeah, because 5 and 1 still add up to 6. Yeah, cannot cross out anything. Yeah, I don't see that. Again, I mean, we can't have two small values, but that doesn't mean we can cross it out. Okay. Well, let's go ahead and I guess test criteria card C, the number of ones. Okay, so the Turing machine does not approve of the fact that I have an absence of 1. So there is going to be a single 1 digit. So we do have a 1. Okay, so let's go ahead and type that up in our notes, and we'll say that the solution has a single 1 digit. Okay, now we don't know whether it's square or circle. If it is square, that forces triangle to be 5, but if not, then yeah, it's wide open. I think I'm just going to have to retest criteria card D. Okay, so it is true that the sum is equal to 6, since my 2 plus 4 does equal 6, and the Turing machine approves of that. So let's go ahead and cross in our notes the fact that it's not going to be greater than, and it is equal to 6. Okay, so that's helpful. What does that mean? Well, that means that triangle cannot be a 3, because the only way you could add a 3 with something else to get 6 is another 3, and we can't have duplicates. So we know it can't be a 3, which means that in square now, it can't be a 3 either. Square can't be 3 because you can't add it to anything to get 6. And it can't be a 4 because there's no 2. And you can't have a 5 because you can't add triangle 1. So yeah, so there is that little bit of symmetry, right? It could be 4, 2, or it could be 5, 1. And we do have a 1 now. Okay, so let's do this. I think we might have to... Oh, this is interesting. Because it's not a 3, well, yeah, I don't think this really helps. Because it's not a 3, we can cross out the equals 3 part. And yeah, I mean, obviously, yeah, triangle's greater than. Okay. So we sort of deduced that. Let me just put in our notes here that we deduced it. Okay. So what else? Okay, so I think it might be worth writing some of these potential solutions. So let's see. All right. Well, if it's 4, let's write it out. So 4, 2, it would have to be a 1 since we do need a 1 digit. That's a fact. Okay. And I believe that's it for 4. Oh, yeah, because the first 2 do have to add up to 6. Then we could have 5, 1. And then because of the no repetitions, it forces us to pick a 3. So the distinction is that we have a descending solution and a no order. So let's take a look. I think that should be it. 421 and then 513. Okay. Are there any clues that would help us deduce criteria card F? Yeah, I don't see anything that really would help us come to that conclusion. So we might just have to do a quick third round proposal. Let's see. Yeah, I don't see anything here that might help us. Okay. Well, let's see. Let's see. Well, the only thing I can think of, and this may be a first, is that if we knew it was in ascending order, we would know definitively that there could be no repetitions. Because by definition of ascending, digits are not consecutive, they cannot be duplicated, and so by definition of ascending as well as descending, that would mean that you could not have any repetitions. Is that sound? If it's ascending or descending, by definition, they'd have no repetitions, which would mean that this card is irrelevant. And so therefore, I think that's what I'm going to do. I'm going to say we're going to deduce that the solution has no order. And again, because if we knew it was ascending, there would be no repetitions. That's the very definition of ascending and descending. Okay, so that would mean that it could not be 421. So let me go ahead and cross it out. And so we're saying basically it's 513. So let's go ahead and cross out the 4. Cross out the 2. And cross out the 1 and circle. And of course, because of the duplication, you can't not have circle be 5. They're all unique. Okay, so it looks like, 513. Well, let's go ahead and type that up. All right. Okay, well, let's quickly review, just in case. So we deduce that triangle should be greater than 3. Yeah, that first digit is 5. That's bigger. The last digit is odd. It is. It's a 3. There is a single 1 digit. Yeah, it's our square value. The sum of the first 2 is 6. Yeah, 5 plus 1 is 6. No repetitions. That's correct. And there's no order. Okay, well, let's go verify 513 as our solution. All right, 513. Fantastic. Okay, so that deduction paid off. Well, how did we do versus a Turing machine? Well, let's go back. So this was a 6 criteria card puzzle, and we only did 6 tests. So that's always a good prospect to at least tie. And we did test BDE in the first round, and then we did ACD in the second round, and we were able to deduce criteria card F outright. So let's go ahead and type that up. So again, BDE in the first round. So B and D were incorrect. E was correct. In the second round we did AC, which I believe were both incorrect. I believe D in the second round was correct. And again, we did skip F outright. So how do we do? Okay, so we beat the Turing Machine by one question. Well, this was definitely an interesting puzzle in the sense of, how it played out. I do have a request, I guess. How did you solve it? Had you ever thought about criteria cards E and F in that way, that we were able to deduce that there should be no order because of the fact the definition of ascending and descending would result in something that had no repetitions. So that would be sort of a redundancy, making criteria card E irrelevant. Have you ever used it? Please share your thoughts and whether you have. Also, if you solved it in a different way, please share that. If you liked the video, please do give it a thumbs up so that more people can find this channel. And of course, don't forget to hit subscribe so you don't miss out on any future videos. Well, until next time, have a great one.